Hello everyone and assalamu alaikum. So we are from group 1. We are going to present about the regional geology in Japan. Anyway, good evening to all the lecturers and my dear friends. So this is our report contents. Part 1, Introduction. Part 2, Tectonic Setting, Stratigraphy, Rock Units, Structural Geology and Geological Resources, all in Japan. This is us. This is our members. First of all, it's me in the first picture. I am Siti Nur Fazila binti Abdul Rasid. So for the next slide, the next presenter is Nur Azalina.
Hi, I'm Azlina and I'm going to do the introduction part. So, the geological history of Japan began with the breakup of the Rodinia supercontinent at about 750 years million ago. Japanese archipelago formed as the result from tectonic plate subduction process at about 500 million years ago. It was the Paleo-Pacific Oceanic Plate was subducted beneath the continental margin of the South China Block. And Japan have four main islands which are Hokkaido, Honshu, Shikoku, and Kyushu. Japan also located northwest of the Ring of Fire above several tectonic plates. The Japanese Ring of Fire is surround the basin of the Pacific Ocean and shaped like a horseshoe. The seismic activity in the Pacific Ring of Fire region is very active because of the continuous subduction between the oceanic crust and the continental crust. The subduction process will produce friction where this friction can cause catastrophic events occurred such as earthquake that will lead to the risk of tsunami. That is why Japan can be set among one of the world's geologically unstable areas. For example, the Tohoku earthquake happened in 2011 in Japan also caused tsunami to happen, and it caused considerable loss of life and widespread of destruction. Moving on, we're going to talk about tectonic setting, where the tectonic setting of Japan is located between the Eurasian Plate, the Pacific Plate, and Philippine Sea Plate. For Japan tectonic setting, the most significant tectonic recorded as the geological of Japan are subduction accretion, paired metamorphism, arc volcanism, back arc spreading, and arc-to-arc collision. The major accretionary complex in Japan island most in the age of Permian until Cretaceous, and the two major accretionary complex during the Permian age is Akiyoshi and Ultra Tamba Belt, while metamorphic event in Japan are divided into two types, which is low temperature and high pressure, and high temperature and low pressure type. During Cenozoic time, the most important geological events are back arc opening and arc-to-arc collision. The major back arc basin are the Sea of Japan and the Shikoku and Chieshima basin, while arc-to-arc collision occur between the Honshu and Izo-Bonin arc and the Honshu and Chieshima arc. There are two stages for the arc collision. The first stage of the collision was caused by the westward movement of the Oorcos plate against the Eurasia plate. while the second stage occurs when the Chieshima Arc collides with the western part of Hokkaido. Thank you. The next slide will be presented by the next presenter.
Assalamualaikum and good morning. My name is Waraida binti Marzuki. I am going to present the stratigraphy of Japan. So we are going to focus to these four domains of stratigraphic units, which is Northeast Japan, Central Japan, West Japan, and Southwest Japan. The stratigraphic sequence are classified in the Quaternary period and the Mesozoic to Cenozoic era generally, along with boundary correlations with the sea surface index of oxygen isotopes, enabling the study of correlations. Why? Because stratigraphy in Japan is closely related to volcanic activities and marine activities. So in the northeast, there's 7 formations that we are going to study. Central Japan is 3 formation, West Japan 5 formation, and Southwest Japan 3 formations. The stratigraphy in the northeast, the occurrence is the lithological boundary were determined by sandstone, intercalation, or the alternating beddings of sandstone and mudstone. The horizons and the lithofacies now. The horizon, the middle part of the Kashima have traphaceous core sandstone beds. Lower parts of Kashima is greenish traphaceous core sandstone. Middle part of Saku Formation have greenish gray traphaceous muddy sandstone with abundant of fossils. Lower middle part of the Hikage-no-Sawa Formation have sandstone conglomerate beds alternating. Maruyama Formation have felsic tuff and traphaceous sandstone beds. Middle part of Shuparogawa Formation have polystrostrom or debris flow deposits of limestone blocks. So now we are going to look at the stratigraphy in the central. The stratigraphy of the Tertiary group have started in the early Cretaceous in the Hakusan region and was studied based on ammonoid biostratigraphy. So the Kuzuryu subgroup consists of conglomerates, gravel sandstones, sandstone in flakes. The lowermost part consists of conglomerate vessels, and the uppermost part is marine deposits. In this area, the total thickness is around 1,000 meters. The Itoshiro subgroup consists of conglomerates, gravel sandstones, sandstones and flake. The lowermost part have marine deposits and the other part is non-marine. The total thickness is 580 meters. The Aikawa subgroup in this district consists mainly of sandstone, flake, and tuff. The Aikawa consists of mainly sandstone, flake, and tuff. So mainly in the central stratigraphy of Japan have sandstone, tuff, and flakes, and maybe a little of conglomerates. So the stratigraphy in the west is divided into 2 groups, which is Toyora group and Toyonishi group. Toyora group is about Lower Jurassic to Middle Jurassic, and Toyonishi is Upper Jurassic to Lower Cretaceous. The Koyosui Formation is further divided into Nakao sandstone and Nanami sandstone. So based on this diagram, Toyora group have a lot of ammonite fossils, and the Toyonishi group have a lot of plant fossils. The last one we are going to look in the southwest. In this southwest, there is a group of calcareous nanofossils from the Upper Miocene to the Pliocene called the Shimajiri group. There's 3 types of Miocene to late Pliocene fossils that have been identified, the main fossils. This occurs in the state of increased eutrophication. So eutrophication is likely due to an increasingly shallow sediment basin. The Shimajiri Group consists mainly of mudstone and sandstone. The Shimajiri Group preceded the Ryukyu Group, which consisted of Pleistocene and Carbonate corals reefs. Between these two is a lithophilic transition, the Jinin Formation. For Yonabaru, there's siltstone and sandstone. Shinsato, tar sandstone and siltstone. For Jinin, have calcareous sand.
Hi, my name is Melissa and I will continue with rock unit in Japan. There are three types of major rock unit in Japan, which are sediment rock that consists of sandstone, limestone, shale, and mudstone. Next, we have igneous rock that comes with two types of rock, which are plutonic rock and volcanic rock. Example for plutonic rock is granite or granodiorite, and example for volcanic rock is andesite. The third unit rock in Japan is metamorphic rock, such as hornfels, gneiss, and schist. We look at the types of rock unit with each distribution in Japan. As we can see from the rock distribution map, there are sedimentary rock from age quaternary to Permian, while metamorphic rock age from Paleogene to Permian, and volcanic rock age from quaternary to Cretaceous, while plutonic age from Paleogene to Jurassic. We look at the example formation for each type of rock. For sediment rock, there are many formations of cave. For example, Cape Sempa at Nakagami, Cape Kamui in Sakatocho, and Cape Manzomo in Okinawa. All of these capes made of limestone. There are also Murawan Formation that made of combination of shale, tuff, mudstone, pumice, sandstone, and also it has fossil. Igneous plutonic rock that are granite with 11.6% distribution in Japan. Known as Mikagashi rock, granite is the most rock that can be found, followed with Inada granite in Honshu and Takadani granodiorite. For volcanic rock, there is andesite in Yakada mountain and lava domes. Another example for volcanic formation is Teitiwa rock, Tanjibu cliff, Hashigui rock, and Tatigami rock. Metamorphic rock formation, for example, there are Susa hornfels formation that made of sediment rock, igneous rock, such as basalt, and rhyolite metamorph, such as schist and gneiss. You can see the layered of black and white in this formation, followed by Tatsubaka formation that age from late Jurassic to early Cretaceous. There are aphyolite sequence that can be found in Japan. The sequence is a section of earth oceanic crust that underlying upper metal that have been uplifted and exposed above sea level and often placed onto continental crust rock. For the first layer, we have sediment followed by pillow basalt as the result of the rapid cooling of hot fluid magma that comes into contact with water. The intermediate layer follow with sheeted dikes that consist of swarm of basaltic dikes, the channels for the overlaying pillow basalt. Next, we have layered gabbro, usually painted and layered, resulting from the crystallization in the magma chamber of the base of the crust. For the bottom layer, we have layered ultramafic rock, usually in peridotites. This section represents the lower part of the metal and has usually been hydrated to serpentinites. As we can see from the map distribution, aphyolite sequence can be found in Oyama and Yakuno.
Okay, hello everyone, it's me again. So I am going to talk about the structural geology in Japan. So as my friend Warda said in her parts, there are 4 domains in Japan, right? But there are 3 major domains that we have to know. But before that, we have to expert in knowing what the major faults in Japan. First, we have to know that first blue line that you can see here is the TTL, Tanakura Tectonic Line, and as known as TTL. And the second blue line is Itaigawa Shizuoka Tectonic Line, is known as ISTL, and the red color there, the line in red color is median tectonic line or MTL. Okay, so if we want to know the major domains, we start with the first domain, northeastern Japan. So as we know, northeastern Japan expanding into north of Tanakura Fault. So you can see the first fault here, all above the first, all and above region on the first blue line is the first domain. For the central Japan is between the Tanakura Fault and ISTL. So between the two blue line is where the second domain. And for the southwestern Japan, extending to south of the ISTL. Okay, you see the ISTL there, the second blue line. Below that is the third domain. I hope you understand. So MTL is also known as the longest fault, about 1,000 kilometers. It was a left lateral strike slip fault during Miocene, but now it's a right lateral strike slip fault. For TTL, it's also a strike slip fault during early to middle Miocene. And ISTL also during Miocene and Pliocene. TTL it's because the opening of Japan Sea, by the way. Okay. So the next one is we can see lots of geological structure in Japan. As you can see that the northeastern Japan, we can see Nemuro Belt, Hidaka and Tokura belts. Central Japan, we can see from 10 to 17, I guess. Juetsu Belt, Ashio Belt, Ishiroke Belt. And for the southwestern Japan, we can see from 18 to 28. Okay, all the structural geology that other than the fault. I think that's all from me. And to the next presenter, Melissa. Thank you.
Hi, continue with me again, Melissa. This time I will present about geology resources in Japan. Mineral resources that mainly found in Japan is zinc, coal, copper, lead, and iron ore. There are other minerals that can be found in Japan, but they are in a small quantities, such as nickel resources, cobalt, nitrate, bauxite, and aluminium. Based on the mineral distribution map in Japan, we can see coal field can be found in Honshu, and Hokkaido, while copper can be found in Kamashi, Yokohama, and Shikoku, followed by iron ore that can be found in Osaka, Kobe, and Tokyo. Lead as well can be found in Kamashi, Akita, and Noshima. Zinc can be found in Honshu area and a little bit in Hokkaido. Coal is the one of the most minerals that have been exploited for economical purpose in Japan. The other use for coal industry is to generate electricity. Coal mainly can be found widespread in Japan islands such as at Hokkaido, Kyushu, and Honshu area. Besides that, Japan also import coal from the other countries such as United States, Indonesia, and Australia because it is cheaper than the domestic coal in Japan. Another resources that mostly being used in Japan is limestone. There are many limestone resources in Japan because there are many formations from coral and dead ocean organisms such as shell animals in Japan island. The use of limestone is to be a material in construction industry, for example, cement, and as well fertilizer in the field of agriculture. Next is oil and gas resources in Japan. To be clear, Japan don't have many of these resources. There are only a few areas of oil and gas resources that can be found, such as in Hokkaido, Yufusu, Akita, and Ayukawara, also in Yurihara, Yamata, and a few in Niigata. The large resources in Japan is geothermal. The use of geothermal is to generate power of electricity, greenhouse, bathing, and plantation purpose. The geothermals come from volcanic activity, such as hot spring, and it becomes one of attraction to tourists. Example in Kwanshu area be found in Orikiri, Otake, and Takigami. That's it from us. Thank you.